Okay, so we're given the velocity of a particle moving on the horizontal x-axis at time t. And we're asked in part A to find essentially its position, yeah? Okay, where is it at time t? Now, what we need to remember is that velocity, okay, it simply measures how fast it's going, yeah? And the rate at which displacement is changing, okay? So, if you think about those words there, it's looking at the rate of change of displacement. That's what velocity is. So we could rewrite velocity as dr by dt, essentially looking at how displacement changes over time, okay, with respect to time. So, you know, it's like looking at the gradient, if you like, of the displacement. So the steeper the gradient, okay, means the faster it's going. Okay, so it's covering more ground with respect to time. Okay, so if we remember that velocity is dr by dt, the rate of change of r, what we can do then, instead of writing it as v equals, we can write it as dr by dt equals, and then we can integrate, okay, with respect to time. Okay, now if we integrate with respect to time, dr by dt becomes r. Okay, that's what we get there. Alright, so we integrate in velocity and we get r. So all I need to do is integrate the right hand side and I'll get r then, which is my position, okay, my displacement. It'll be an expression for displacement at time t. So when I integrate this, remember you add to the power, so it becomes 2, divide by 2. You add here to the power, so it becomes 3, divide by 3, plus then a constant, okay? So we get, this becomes 6, doesn't it, t squared, that just becomes t cubed, plus c. We've got to have a constant when we integrate, and there's no limit. However, we can actually work out the constant because it gives us a condition, doesn't it? It says when particle is at O, okay, at the origin, in other words, the displacement then will be 0, yeah? R will be 0 when it's at the origin. Displacement in terms of its position relative to the origin, well, it's nothing. T is equal to 1, okay? So that situation applies there, okay? So we can put it in, so R is 0, T is 1, okay? And we can work out our constant from there. So this becomes 6 take away 1, sorry, plus C, and the overall answer becomes 5, doesn't it? Okay, there. 6 take away 1 is 5. So then that means C then is going to be equal to minus 5, and I take it over. So therefore, R is equal to 6t squared plus t cubed minus 5. That's the position there at time t. So this is displacement at time t. Part B then says find an expression for the acceleration time t. Well, if we know the velocity is 12t minus 3t squared, okay, to get the acceleration, now remember, acceleration simply measures the rate at which velocity is changing. So it's looking at how speed changes. Okay, so the faster speed changes, the greater the acceleration. Yeah? So that will be looking at the rate of change of v, so that's dv by dt. So you've got to differentiate v. Okay, so we get 12 when I differentiate that there. And then when I differentiate this, well, I'll bring the 2 down, so it becomes 6t. Okay, so we've got an expression there for the acceleration at time t.